In this lesson, we're going to look at separable differential equations. Now, separable differential equations are called separable because we're going to involve x and y, and we can pull them apart, separating the x and y variables. Notice that often in these equations, the x and y will be mixed, but we want to move all of the y's to one side, all of the x's to one side. Also, remember that we started with dy dx being equal to some equation in terms of x and y. And so when we move it, we're going to have a dy on one side and a dx on the other side. And then we're going to turn each side into an integral. And so we should be able to integrate each side to get a general antiderivative. And when we want to solve the thing, to be solved, it should be an equation y is equal to. So we're going back from dy dx to find y. So for example, this equation here, I have dy dx, it's equal to x over y. So I have both x and y in my equation. So to solve this, I want to start by moving the dx to the other side. I can also multiply both sides by y so that I bring the y over to this side, and I'll leave the x here, leaving me with an equation like this. I want to integrate each side, so the antiderivative would be 1/2 y squared, and also 1/2 x squared. Now remember, we should also put plus c when we're taking an antiderivative, but since this is an equation, I only need that on one side. Think about it like this. I'm adding a constant on this side, and I'm adding a constant on this side. My next step would be to move the constant over here, and it's going to make a new constant. Okay, now they're not necessarily the same constant. We don't know what it is, but I really only need that constant on one side of my equation. The next step then, I'll need to solve this equation for y. And so I'll multiply both sides by 2, which will give me x squared plus, now it'll be tempting to say 2 times a constant, but if I have a constant and multiply it by 2, it will still be a constant. So we'll just leave it as plus a constant. And my final step to get the y by itself, we'll take the square root of both sides, but we're going to use plus or minus the square root to include all the possible solutions of this, because this equation here will give me the slope for all points in the x and y plane, so it would include both the positive and negative values. This next example is a little bit more involved, and that's why I did the other one first. So if I start with dy, I move my dx to the other side, I'm going to multiply this squared in, so I'm looking at x squared, y squared. Then when I move this over, well, this will be y to the negative 2 dy and x squared dx. We're going to turn each side into an integral. We're going to integrate. That would give me negative y and 1/3 x cubed, and this is the side that I'll put the plus a constant on here. Now in this problem, they give us a specific value, which means we're not going to keep it general with the plus c. We need to work that out and find what it is. A lot of times this will be easier before I solve this for y, because this plus c might get a little bit complicated in this one. So I'm going to go ahead and substitute that now. This would be negative 1 over 1, or really just 1. 1/3, x is 1, so we just leave it like that. And so I'm going to get c is equal to negative 4/3. And I can substitute that into my equation. Coming back up to here, we'll substitute that 1/3 in. I'm also going to change my y to a negative 1 over y. And next I'm going to combine my fractions here. Since they're both over 3, I'm going to write this as x to the 3rd minus 4 over 3. Because I need to flip this fraction over, I've got negative 1 over y. So to get y is equal to, I'm going to flip this over, and since I have that negative, I'm going to bring it over. So this would be the solution to my separable differential equation, because I have y equals everything else. It always has to be y equals when we're talking about a solution to a separable differential equation.